So, the first question is, why is there really only one parabola in the world? And that's because all parabolas are shifts, stretches, and reflections of the parent function, which is y equals x squared. All right, so on slide 6, you typed in f of x minus 4. How did it shift the parangula? How did it shift it? Right. Okay, and so this first table that you guys typed in is just shifting. And so I was walking around, you guys looked like you were doing really well on shifting. And so from this right here, we know if I want to go from black to red, I want to go to the right 3. So that would mean I would subtract 3 on the inside. And then to go from the black to the orange, so you guys can't see colors on your paper, but the orange is this one. So what would I do? And where would I do it? You're going to add 4 on the inside, right? Okay. And then the green was the one most people ask me about. And so we want to go down 4. So when you're going down 4, you have to subtract that 4 on the outside. And then to get to the blue, we're doing left again, left 6. So that's adding 6 on the inside. So do you guys remember that from last year, or it kind of came back to you? Good. Okay, the stretches and reflections are definitely more difficult to do, particularly the stretches on the horizontal stretches and compressions. So we have this black one that we want to rewrite or transform until we get this red one. So one of the things that's not too terrible on this particular problem is that it went up 3. So what do I do to go up 3? Up 3 you add on the outside. Don't put the X there yet, sorry. Okay, and so if you look at the black one compared to the red one, they're the exact same height. But what changed is it got narrower, so the width changed. Did anyone find a way to make this work? It's a tough one. All right, so what works is if you do 2x plus 1. So the 2 and the 1 and the addition actually makes it shift a half to the left, which is weird, but it does. And then the 2 multiplied by the x on the inside makes it half as wide as the original problem. And we'll talk more about that later. All right, did anyone get the orange one to work? It's okay. So the orange one, if we're comparing the black to the orange, it's half as tall. And so the height changed to half as tall, so we do a half on the inside, half on the outside. What else happened to the orange? Shifted to the right, right? All right, so then we subtract 5 on the inside. All right, did anyone get the blue one to work? Might not have given you enough time. The blue one flips upside down. And so a reflection is going to be a negative. All right. It also shifted left 6. So that's x plus 6 on the inside, and then down 3. All right. So based on what you learned in this Desmos activity, what is the difference if we took the original parent function, which is y is equal to x squared? what's going to be the difference between subtracting 4 on the outside and subtracting 4 on the inside? What is subtracting 4 on the outside going to do? Down. What about subtracting 4 on the inside? It's going to be right. Okay, and then the difference between multiplying by 3 on the outside and multiplying by 1/3 on the outside. Multiplying by 3 on the outside is a vertical stretch, so it's going to make it 3 times as tall. And then 1/3 on the outside is a vertical compression. So it's going to be 1/3 as tall as the original one. Okay, so let's flip over and look at the table on the other side. That's going to have all the different transformations. And I've divided them into when you do something on the outside of f of x and when you do something on the inside. So do you guys remember, or even like here, whenever it was on the outside, like the -4 and the 3, did that change the function vertically or horizontally on the outside? Okay, so it's definitely vertically. So moving down and up is a vertical change. So when things are done on the outside, it's going to be vertical changes. And when the transformations happen on the inside, it's going to be horizontal changes. Okay. And so I guess we didn't do one where we actually added, yeah, we did, on the very last one. So when you add on the outside, it's going to shift up. And when you subtract on the outside, it shifts down. So adding and subtracting is always a shift. Multiplying is called a dilation, but a lot of times I'll just say shrink or compression. I'm pretty sure that's what your Algebra 2 teachers also said. So when you multiply on the outside is going to be a vertical change. And when you multiply by a small number, like a number between 0 and 1, which will be a fraction like 1/2 or 1/3, it's going to be a vertical compression. Barely fit that word in there. Right, when you multiply on the outside by a bigger number, like 2 or 3 or 5, that's going to be a vertical stretch. All right, and then a negative, it multiplied by the function always is a type of reflection. To reflect, a vertical reflection is going to be on the outside. It's going to be reflection on the x-axis. Okay, and then when things happen on the inside, it's going to be a horizontal change. And one thing I want to tell you about the inside, and your Algebra 2 teacher might have told you this also, is that the inside is a liar. So it's going to be the opposite of what you think it should be, because it lies. So adding and subtracting is still a shift, but it's going to do the opposite of what you think. So adding on the inside is going to shift in the negative direction. It's going to shift left because the inside is a liar. Subtracting on the inside is going to shift right. All right, Multiplying is still a dilation which stretch and compresses your function, but the smaller number stretches and the bigger number compresses because the inside is a liar. So multiplying by a small number on the inside is going to be a horizontal stretch. Now, today, and even tomorrow when we practice, when you're giving the transformations, you don't have to say stretch by a factor of blah, blah, blah. But for something else we might have to do, we're going to go ahead and write it today. So we're going to horizontal stretch by a factor of, and then it's going to be the reciprocal of whatever you're multiplying by. So if you multiply by 2 on the inside, it's a horizontal, if you multiply by 1/2 on the inside, it's a horizontal stretch by a factor of 2, whatever the reciprocal is. I'll remind you that later too. All right, and then multiply by a big number on the inside is going to be a horizontal compression. And then again, it compresses by a factor of the reciprocal. So if you multiply by 3, it's going to be a horizontal compression by a factor of 1/3. Okay, and then a negative on the inside is going to be reflection over the y-axis. Now, I had a student a long time ago, like she's in her 30s now. She probably has kids. But she said something I still remember. The way she remembered that the inside was the y-axis, she called it the yin side. So y and yin, I don't know, inside. Still how I remember it. It's how I keep it straight in my head. Okay, so let's do a few of these where we're going to identify the parent function, which we already practiced that last week, and then we're going to list all the transformations. So when you're doing the parent function, you just strip away all the multiplication, addition, and subtraction. And so what does that leave you with as your parent function on this one? I can't tell if you guys just don't want to talk to me or if you don't know. Yeah, okay, x squared. That's the type of function it is, a quadratic function, and that is also its parent function. Okay, this one has 2 transformations. One of them is multiplying by 2. Would you say that's on the outside or inside? It's on the outside because there's no inside. There's no parentheses. It has to be parentheses or brackets or something for there to be an inside. So multiplying by 2 on the outside is going to be a vertical stretch. And you don't have to say by a factor of whatever. You can just say vertical stretch and be done. Right? That minus 3 is on everything is on the outside on this one because I don't have parentheses. So subtracting 3 on the outside is going to be down 3. All right, what do you guys think about the parent function on B? Absolute value, good. All right, what about subtracting on the inside? Which way? Right 4. Okay, you guys try to do C on your own. So the parent function here should be y equals x cubed. What is that negative going to do? X-axis, good. So it's on the outside, so it's going to be a reflection on the x-axis. And then what about that 4? Multiplied on the inside, greater than 1. Horizontal compression, good. Okay, you guys remember this from last year? Most of it? Okay, good. All right, number 2. I'm not sure if you all did this. It probably depends on, or if you did ones like number 2, it probably depends on if you were in honors or regular or whatever. But we want to give an equation of the parent function y equals the square root of x after it's been shifted left 7 and up 2. So I'm going to call this f of x. We can call it whatever we want to, but I'm going to call it f. If the parent function is the square root of x, we do have to have the square root of x in our new equation, but we're going to do some stuff to it. So if I want to go left 7, what do I do with 7 and where? We're going to add it inside or outside? Good. All right, up 2, we're going to add it outside. Okay, so this is going to be left 7, and this is going to be up 2. Okay, and then this multiple choice question, I'm going to go ahead and just draw the parent function for the parabola. You guys did this on last week, but sometimes it helps to see it. All right, so this was the parent. And then the green one is G. That's been shifted. It's been dilated. And what's difficult with parabolas is the vertical stretch and the horizontal compression look the same. So focus on the shifting, and I think that you'll be able to pick it out. So you guys look at those answer choices and see if you can figure out which one it is. Right, 2 down 4. Yes, good. Right, and then this technically is a vertical stretch. So it's taller than the original. But like I said, with a parabola, that looks very much like a horizontal compression, so you have to be careful. Okay, and then this last one kind of threw people off last period, but I don't know, maybe they overthought it. But Pilar's parents give him an allowance amount A of t based on his age, which is t years. Which of the following expressions would give the allowance amount for his sister, who's younger, who's 3 years younger than him? So do you think we should take that 3 and subtract it from his allowance, add it to his allowance, subtract it from his age, or add it to his age? Which choice do you think it would make sense? Definitely C. 3 years younger, you subtract 3 from his age. Okay.